Today we will be solving verbal system of equations with substitution. When writing a system of equations from a verbal description, remember the first thing you want to do is define your variables first. When solving a real-world system of equations, you need to make sure the solution is reasonable. There are values in the equations that say could be negative for length, but that does not mean in a real-world situation that could be possible. That could be a possible answer. So we want to make sure we are mindful of those situations. Getting into our examples. Example 1 says the length of a rectangle is 6 inches longer than the width. If the perimeter is 72 inches, how long is the rectangle? So what this question is actually asking is how long our rectangle is. But it doesn't give us specifically the length or the width of our shape. So in this case, we have to use our system of equations by creating two equations and then solving for each variable. We know that we're dealing with perimeter. If I can get this to snap where it needs to go. Dealing with perimeter, which means that we are going to have a variable L and a variable W. I want to keep that lowercase l. Our L is going to stand for the length of the rectangle, and our W is going to stand for the width. If I can type everything correctly. Now, if we look at the first sentence, it says the length of the rectangle is 6 inches longer than the width. So this is setting up the equation that our length, L, is, need that lowercase, our length of the rectangle is 6 inches longer than the width. So the length of the rectangle is 6 more than, plus 6, the width. So that would be our first equation. Our next equation, if the perimeter is 72 inches, so this is where we would use the normal perimeter formula. Perimeter equals 2 lengths plus 2 widths, but it's letting us know the value already. It is 72 inches. So now we have two equations that both have the same variable. Normally before this, if we had a setup, we always wanted it to where it only gave us one variable left in our equation. But that's not the case here. Both of these have a length and a width in the expression, or in the equations. So this is where we'll go to our next step. We'll combine our last two lessons, where we'll solve for a single variable. Our first equation is already set up where length is by itself. So if we choose this one, we're already finished with the first column. We can move over to the next one. The next column, we want to substitute in the value, the expression from the first column into our other equation. So first we want to type it out. then show that we are replacing, in this case, the length L with our expression. The length is multiplied by 2, so we need to show parentheses to indicate that we are multiplying by 2. And we're still adding our 2w. Now that we substitute in our value, we only have one type of variable in the whole equation. So we can start to simplify. First by distributing. 2 times w is 2w. 2 times 6 is a positive 12. And we still have the plus 2w. From here we can combine like terms. 2w plus 2w is a total of 4w. And we're not doing anything with the 12, so we just write it back. We have 2 more steps. We want to subtract both sides by 12. So we'll have 60 equals 4w. Make sure I do my math right. Don't want to mess up on any of the easy ones. And we solve by dividing both sides by 2, or by 4. We divide both sides by 4, which will give us a width of 15. Now for this situation, we're still looking for the length, so we still need to finish out our problem. We need to go to the third column. The third column, we rewrite our first column's equation. Make sure you use the proper variable. We have a specific value for w now that we can plug in. One day I'll go and look into the automatic rules and change that so I stop having to go back and lowercase my variables. Last step, combine our like terms. 15 and 6 combined will give us length equals 21. So specifically for our problem, it asks if the perimeter was 72, how long is the rectangle? The answer to this problem isn't our solution like we had earlier, but specifically the length is equal to 21. If we look at our units, it's talking about inches, so I can write in inches. Highlight it all. Example number 2 goes back to our money. It's talking about quarters and nickels in his pocket. It tells us that he has 8 more nickels than quarters. The total value is $3.70. How many quarters? So how many quarters does Eric have? And how many nickels? It is asking for both the variables. So no matter how we set this up, we still need to find each variable. We'll go through the same process. We're talking about quarters and nickels this time. I had to check to see what I was talking about. Quarters and nickels. Now our equations. It says that he has 8 more nickels than quarters. So our total number of nickels is, let's get that right. Total number of nickels is 8 more than the number of quarters he has. So we want to show that our nickels is equal to our quarters plus 8 more. Then we have the total value. This means if I add all my nickels and quarters together, I should get $3.70. I need the value of each. My nickels are 5 cents for every nickel, plus 25 cents for every quarter, and this is going to equal my $3.70. So you need to make sure that you use the right value. Some people end up just putting 5 and 25, forgetting that we're talking about cents here in the form of a dollar. The 3.1 is showing us in the dollar form. So now, yet again, we have a variable that's by itself. We can use the first equation. In the second row, we can use the second equation, substitute in our value. We know what the value of n is. It is multiplying to 0.05, so I need to show that. So I'm just writing the rest of it out. All I wanted to do is show that I replaced my n with q plus 8. I want to distribute properly. 0.05 q plus 0.4. And then the rest of our equation plus 0.25 q, the original price of each quarter, equal to the total, which was $3.70. Now we can combine our like terms. So 0.30 q plus 0.4 is equal to still our $3.70. We can subtract 0.4 from both sides. And our last step is to divide by our 0.30, our coefficient, which gives us our quarters equal to 11, which in this case would answer our first question. How many quarters does Eric have? As of right now, he would have 11. Looking over at our last equation, our section, sorry, we have our nickels are equal to our quarters plus 8. When we plug in the value, our nickels is going to equal the 11 quarters plus the fact that he had 8 more nickels. So our total amount of nickels is equal to 19. We could plug this into our original equations to make sure that all of our values, our equations, are correct. To finish this off, our last example, before we finish this whole video. The manager of a movie theater wants to know the number of adults. So it's already telling us what he wants to know. He wants to know the number of adults and children who go to the movies. It says the theater charges $8 for each adult and $4 for each child. At the showing, there were 200 tickets sold. So that's giving us the combination of number of adults and number of children sold, and the theater collected $1,304. So our total price for the tickets will combine with the $8 for each adult and $4 for each child. It wants to know how many children and adults attended. So I did that in the order where they match up. It automatically stated that he wants to know how many adults and children. So these two underlined sections are the same as our question at the very bottom. Oops, need to go to my actual settings, switch over to text. My variables for this situation. A for number of adults. And C for number of children. So this is linking back to our old problems that I've already discussed in an earlier video. How we're going to use a variable that works with what we are actually referring to. A for adults, C for children. It says that 200 tickets were sold, our tickets being adult tickets plus our children tickets. And this is equal to our 200. Our second equation will talk about the price and rate for each adult and child ticket. We know that it is $8 for every adult plus $4 for every child, and they earned a total of $1,304. So this helped create our two equations. We can now start the solving process. Now I'm going to use the first row because it has a simplified rate. Both A and C are by themselves. I can plug it in. I can solve for either variable. I'm going to choose to solve for A, which means I need to subtract C from both sides. I now have A by itself. I can go to my other equation. I can replace my A with its known expression. It is multiplied by 8, so I use the parentheses to show multiplication. I finish out my equation, not just the expression, but the equation. I start the simplifying process. I have one more step to simplify, combining my negative 8c with my positive 4c, which would be negative 4c. Still have the plus 1600. And this will equal the 1,304. I'll subtract 1,600 from both sides. And now I actually do the solving methods, which is divide both sides by the -4, which will give me C equals, let's lowercase that, actually see what this is, a positive 74. So what this is saying is that we had a total of 74 children at the movies. For our last row, we take our first equation, we substitute in the value we found in the second column, there we go. Get that all nice and neat. Proper variables, right value, finished expression. I can subtract 74 from both sides, and I'll get the adults is equal to 126. So what this means is I had 126 adults at the movies. So in this case, I had more adults. This is where they may focus on selling towards adults.